Hello, welcome back. So this is now our last class for the time value of money section. And we're going to start off by looking at the present value of a perpetuity. So firstly, what is a perpetuity? It's where we get a fixed cash flow forever at set intervals. And to get the present value of the perpetuity, all we need to do is take whatever this fixed cash flow forever is, which we call the payment, and we divide it by I over y. And remember, I over y from the previous class is the interest rate per compounding period that we call the periodic rate. So I just want us to go back to our normal present value formula for a second. I know you know it, but I just wanted us to compare something quickly. So there's our normal present value formula. And there we have the future value, and we divide it by 1 plus I over y to the power of n. Now, with the perpetuity, all that happens, the numerator is now the payment, which is going to be that fixed cash flow forever. We put that into the numerator, and instead of dividing by 1 plus I over y to the power of n, all we do is we divide straight by the interest rate per compounding period. So in other words, all that's happening here with the perpetuity is that the present value formula is simplifying. So let's just go back to where we were, there we are. So we just now got a simplified version of the present value formula. So we can view that then as our future value. So let's just put in future value over there like that. And we don't have to go into all the maths, why this formula simplifies. We'll just know it like this, because it's actually quite complicated to actually look at all the maths as to why this is so. But let's just do the example, and we'll see that it's pretty simple. So we got a preferred stock issued by Chartwell Company, and it pays a $6 annual dividend forever. Now, all we need to know for now is that a preferred stock does pay a fixed dividend forever. And we will be talking more about this when we get to the equity section, but we'll just go with it for now. So to work out the present value of the preferred stock, and they give us their 7% annual rate of return, all we need to do is take that $6 dividend there forever and divide it by the 7% rate, and there we get our value. So it's actually nice and easy. So let's try the next one. Here we've got a preferred stock. It's issued by Foden. Now it's paying a $1 quarterly dividend forever. Now, what is the present value of this one? Given an annual rate of return of 6%, but now we are compounding quarterly. So here we've got in the numerator, the payment, the $1 dividend forever on a quarterly basis. But now the denominator, remember the denominator, it must be the I over y, the interest rate per compounding period. So that's 6%, that is the annual rate. So to get the interest rate per compounding period, all we need to do is what? We take, like we did in the previous class, we take the annual rate there, the 6%, and we divide it by the number of compounding periods per year, which is now 4 because it's compounded quarterly. So then we can see that the interest rate now per quarter is going to be there, the 1.5%. So now for the numerator is on a quarterly basis, and now so is the denominator. So we've got apples with apples there. So now we can see what the interest rate there is on a quarterly basis, and that gives us our value. Good. So now what we can also do, we can rearrange the formula to work out, what is the interest rate per compounding period. All we need to do is take the payment and divide it by the present value of the perpetuity. So let's just do it for Chartwell over here. So their payment was $6. So let's put in 6 over there. And the present value of the perpetuity was 85.71. So let's just put in the 85.71. 85 there, 0.71. And now if we work that out, we are going to get the 7%, right? So the answer there was 7%. So we're going to get 7%. There we go. So it's not that bad, hey? Pretty simple. Now, what about for Foden? So for Foden, what do we need to do? I won't write it all out, but for Foden, we're going to take 1 divided by 66.67. And what are we going to get? We're going to get 1.5% because that's going to be on the quarterly basis. So 1 over 66.67 is going to give us 1.5%. So if we want to get the annual rate of return, what are we going to do? All we're going to do is take that 1.5% multiplied by 4, and we're going to get 6%. Excellent. So now we're just going to have a look at a couple of problems here, because as we discussed in the last class, with our time value of money calculations, we've got the 5 variables, and any 4 of them, we can put them into the calculator to work out the 5th one. So we're just going to do 2 quick questions. And of course, you guys are going to be practicing a whole lot more. And so our first question, we've got Andili. He's purchasing a home for 2 million, and he's put down a 10% deposit, and he's been given a 20-year mortgage from his bank at an annual rate of 9%. So what will his monthly repayment be? So that's the important word there, monthly. So he's going to, the loan he needs, the value of the present value, he's putting down 200,000. So he needs to get a loan there of 1.8 million from the bank. And how many periods are there? Well, he's doing monthly repayments. So there's going to be 12 repayments a year for 20 years. So there's going to be a total number of periods of 240. And now the interest rate per compounding period. So the annual rate is 9. He's paying monthly. So we're going to divide that annual rate by 12. So this means that his monthly rate he's going to pay is going to be 0.75%. And the future value is nothing, because he's going to pay off the loan in full after 20 years. And all we need to do is hit the payment button, and there we go. So that's how much he needs to pay every month for 20 years. Now, what's great about learning these time value of money problems is that you can apply it to yourself. So if you want to buy a house or a car, or whatever, all you need to do is put in the amount and how long the loan is going to be for and the interest rate you're going to get from your bank, and you can work out what you need to pay monthly. So it's got great practical applications for us, which is excellent news. Now let's try this question over here. We've got Kathy. She invested $500 at the end. So that's an important word there. So I'll circle it, at the end of each month for 5 years into an investment account. At the end of the 5th year, her account has a balance of 41,362. So they wanted to work out what is the annual rate of return on her investment over this period. So she's investing at the end of each month. So we must make sure we're in end mode. And she's putting in $500 each month. It's each month there. So I made that a minus sign because I like to think of this money as leaving Kathy's pocket. So how many periods are there? Well, she's investing 500 each month for 5 years. So it's going to be 12 periods a year for 5 years. So it's going to be 60 periods altogether. And the account has got 41,362 at the end of the 5th year. She started with nothing. So all we need to do now is hit the I over Y button. And there we go. So there we go. But it's not that. I shouldn't say there we go. That's not the answer, because that is the monthly periodic rate. Of course, it is the monthly periodic rate. And what are they asking us for here? They're asking us for the annual rate of return. So if that's the monthly periodic rate, what do we need to do? We need to multiply that by 12, and that's the right answer. So on the exam, if they ask something like this, they might make 1.03 one of the answer choices, but what are we going to do? We're just going to ignore that, and we're going to go with this one. Good. So let's carry on then. Now we're on to deferred annuities, and and the best way to understand these is just to do a couple of examples, and that's what we're going to do. So Ben requires an annuity of $10,000 a year for 3 years to fund his son's education. The first payment is due 5 years from today. So assuming an interest rate of 5% per year, what is the annuities worth today? So in other words, what deposit is required today? How much does Ben need to put down today so that he can generate these cash flows? So he needs $10,000 a year for 3 years, 5 years from today. So that's 5 years from today, the end of year 5. So what we're going to do now is we're going to do this in end mode, and then on the next slide we're going to use begin mode so that we can compare. So we're going to he needs 10,000 there each year for 3 years. So we got 3 payments of 10,000 each. And the interest rate per compounding is 5% because we are using here annual compounding because it's 5% per year. And now all we need to do is hit our present value button. But what's the but here? Remember, if we're in end mode, the value of this perpetuity, if we're in end mode, is 1 period before the first payment. And to understand that, let's just go back to the previous class for 1 second. Let's just go back here to the present value. Where are we now? Here we go with Tundi. Remember this when we were in end mode over here with Tundi in the previous class. We're working out the present value of the ordinary annuity in end mode. We worked out the value of annuity there. It was 1 period. It was 1 period here before the first payment. Now that's the same thing we've done with Ben. Okay, so we've done exactly the same thing because we're in end mode. So what have we found? We have found the value of this perpetuity 1 period before the first payment. But we have a problem here because this is a T4 value. And what is the question asking us for? The annuity is worth today. So what do we need to do? We need to discount this T value, this T4 value, to a T0 value. In other words, put it into today's money. So that's going to be our future value. And we've got to discount it back these 4 periods here at our 5% rate. And that is the right answer. So if we work backwards then, what does Ben need to do? He needs to invest 22,404 today over there. And that's going to grow to 27,232 4 years later. And then he's going to invest this in annuity. And that's going to give him the $10,000 per annum for the next 3 years that he needs. Excellent. So now we're going to do the same example, but we're going to switch to begin mode. So I don't recommend this, but some people actually prefer to use it. So that's why I want to show this just for comparison purposes. So everything is the same, except now we're going to use begin mode. So if we use begin mode, what value are we going to find? We are going to get here a T5 value. Why? Because if we are in begin mode, we're going to find the value of this perpetuity on the date of the first payment. So we're going to find that if we're in begin mode, we're going to find the value of the perpetuity on the date of the first payment. So let's just go back quickly again to when we were in begin mode. Remember this over here. Yeah, this one over here with Sarah. Here we were in begin mode. So here we found the value there. And that value was on the date of the first payment. Right, so that's exactly what we've done now when we were in begin mode. So let's just go back quickly to our friend Ben here. There we go. So we are here. So we have found the value of this perpetuity there on the date of the first payment. So this is now a T5 value. That 28,549 is a T5 value. So now to get it into today's money, what do we need to do? We need to discount it back 5 periods if we're in begin mode and not 4. Good. So that working backwards is actually basically the same thing as we did on the previous slide. Fantastic. Right now, this is the last thing we need to look at in our time value of money, and that is the present value and future value of an uneven cash flow series. So if an investment has uneven cash flows, then it's not an annuity anymore, where we can use the payment function on the calculator, because remember, for the payment function, we have to have the constant cash flows. We have to need the same amount every time. So now if we don't have the same amount, then we can't use the payment function. So what do we need to do? To find the present value of an uneven cash flow stream, what do we need to do? We've got to sum up the present values of all the individual cash flows. And to find the future value of an uneven cash flow stream, the same thing. We've got to sum the future values of all the individual cash flows. But here is a little bit of good news. If we need to calculate the present value of uneven cash flows, in other words, these ones over here, then we can use the net present value function of the calculator. So that's good news. I'm going to do an example in a minute, but here's the bad news. If we need to calculate the future value of an uneven cash flows, then unfortunately we got to sum the future values of all of those individual cash flows. So let's try an example. So you will receive, you will receive $400 in 1 year's time, then 500 in 2 years' time, then 700 in 3 years' time at 5% per year. So what is the present value of this income stream? So here we go. So this is now, we're going to get $400 in 1 year's time. So what do we need to do with this one? This $400, we need to discount it back 1 year over here. So there's the $400. We discounted back 1 year. So in other words, $400 in 1 year's time is worth $380 today. And then what about the $500? Well, we're going to discount this one back 2 years. So we're going to discount the $500 there back 2 years. And we see that $500 in 2 years' time is worth $453 today. And then lastly, we got to then discount the $700 here back 3 years. So we're going to discount the $700 there back 3 years. And so $700 in 3 years' time is worth $600 today. So then we've got to sum all of those up. But as we said on the previous slide, the good news is for the present values of an uneven, only for present values of an uneven cash flow stream, we can use that nice NPV function on the calculator. So we just got to plug in our cash flows into our calculator, put in our interest rate, hit the NPV button, and away we go. Now, we are going to revisit this in a lot more detail when we get to the corporate finance section. So we will be returning in a big way to the NPV. Right, and then lastly, let's try this one. So you will invest $400 in 1 year's time, then $500 in 2 years' time, and then $700 in 3 years' time at 5% per year. So what is the future value of this series of cash flows at the end of 3 years? Well, so this $400 we're investing at the end of year 1. So we need to grow this $400 here. We need to grow it 2 years there. We've got to grow the $400 2 years. So $400, we grow it 2 years. So it's going to be worth $441 in 2 years' time at 5%. And then this $500, we've got to grow that one just the 1 year there. We just got 1 year from there to there. So we're going to grow that $500 1 year. So we're going to have $525 there in 1 year's time from that investment. And then lastly, the $700 that we invest at the end of year 3, well, there's no time at all for that to grow because they want us to work out the value of this at the end of year 3, and we're only investing this at the end of year 3, so there's no time for it to earn any interest. So all we need to do now is sum up these three, and we get the future value of that cash flow series. Excellent. So we're done then with the time value of money. I hope that was helpful. So now, as we can see, we need to just practice lots of questions, and we're going to get the hang of this, and we're going to nail it. So just before we leave this class, I mentioned in the previous class that we were going to look at, just briefly, those CFA Institute practice problems. Now, these are the questions that CFA Institute have at the end of every reading in the CFA Institute books. And what I've done for some of those questions is additional notes, and I'm just going to flip over to them over here. And so I call them additions to the CFA Institute readings practice problem solutions. I've done additions to their solutions because in some of their solutions, they don't draw timelines. So where there wasn't a timeline, I've drawn the timeline. And you can see here something similar to what we did in a deferred annuity type of example. And then there's another one there, annuities there, and there's more over there. And then also sometimes, like this question and this question, the CFA Institute were not using the calculator. So I've just shown us the calculator steps over there, for example. And don't worry about this continuous compounding. We're going to do it in the next study session. And there you guys, you'll see there all these. We'll be sending these out to you. If you don't have them, please let us know, and we will send them to you. And those are all the pages I did for that time value of money. And then for the next reading coming up, we've got some more help for you guys in these notes, and I'm sure they're going to assist you. Great. So that is then the end of that class, and we look forward to seeing you guys in the next class. Hello, it's Tim here again. I hope you enjoyed the class and found it beneficial. We have some classes available for free on YouTube, but we have classes for the entire curriculum. The classes that are not on YouTube can be purchased from us. If you'd like to purchase the classes, please contact us for the pricing, and I've put our contact details over here. You can purchase all the classes or certain readings that you would like. When you purchase the classes, we provide you with the slides and our notes. I've assisted hundreds of candidates pass CFA exams, and I look forward to also helping you through the CFA program. I've put in 2 testimonials in the slide over here, and we also have a testimonials page on our website that you can review. I look forward to seeing you soon, and all the best.